Is my screen visible? Okay. Okay. So today we are going to see next group of instruction. Logical instructions. So logical instruction, first instruction is CMPR or CMPM. Right. Example for CMP R is possibly CMP. Right. So this instruction basically done comparison. आता कुणाबरोबर compare करत असेल ते? Exactly, accumulator. So whatever register mentioned in instruction, or if it is memory location, then memory pointed out by HL register. So content from that memory or content from register which is given over there in instruction is compared with accumulator, right? Is compared with accumulator. What internally does here in this operation is it simply subtract the content, sorry, D or memory, right? It simply subtract the content. But next operation, which is result is again stored into accumulator, is not performed in case of comparison. Only, only subtraction is done. Status are set, right? स्टेटस म्हणजे काय तर फ्लॅग रजिस्टर वर त्याचे इम्पॅक्ट येतात and in that case only impact is there in status register or flag register, right? Accumulator rather does not change. Whatever value is there in accumulator is as it is there. Whatever value is there in register or memory is as it is there, right? So it is simply status after subtraction, right? So there are certain meanings available with this. If either register or memory, right? Accumulator is equal to and accumulator is greater than register or those are few conditions, right? एक तर accumulator लहान असू शकतो register किंवा memory पेक्षा तो equal to असेल rather greater than असेल. आता हे कसं कळतं तर कॅरी फ्लॅग सेट असेल, right? Then carry flag reset असेल simply, right? Carry flag set असेल तर हा डेटा ग्रेटर, कॅरी फ्लॅग रिसेट असेल तर हा डेटा ग्रेटर, राईट? वन मोर, आता ह्या दोनच कंडिशन आहेत ना फ्लॅगला, ना मग ही कंडिशन कशी दाखवतं ते कॅरी फ्लॅग इज रिसेट, झिरो फ्लॅग इज सेट. इफ इट इज इक्वल दॅट मीन्स झिरोच यायला पाहिजे ना ते. जर दोन्ही व्हॅल्यू 1 1 1 1 असेल, सबट्रॅक्शन केली काय होईल रिझल्ट ऑब्वियसली सेम असेल, इक्वल असेल तर मग रिझल्ट 0 असेल. इन दॅट केस झिरो फ्लॅग काय होतो, right? So if register's value is greater, carry flag is set. If register value is accumulator value is greater, carry flag is reset. If result or values are equal in accumulator and register, carry flag is reset and zero flag is set, right? This is what simply comparison is. One more important thing, result rather value of any of the register does not alter, right? हे तुम्हाला जनरली विचारलं जातं परत कशाला ओरल एक्झामला की कंपेअर मध्ये एक्झॅक्टली रिझल्ट काय होतं, राईट? रिझल्ट कुठंच येत नाही, फक्त स्टेटस फ्लॅग सेट होतं, राईट? कॅरी किंवा झिरो, एनी ऑफ दी रजिस्टर डज नॉट अफेक्ट, राईट, आफ्टर सबट्रॅक्शन. Next is CPI, 8-bit data. Yes, compare immediately data present in instruction, address data present in instruction. Accumulator is greater than, or content of accumulator is less than data content equal, right? Which is whatever present in instruction and content of accumulator are equal, and content of accumulator is greater than given data, right? So in that case, what will happen here? What will happen? Carry flag is set, carry flag is reset, carry flag is reset, zero flag is that's it. So this is how CPI works. Next is ANAR and ANAM instruction. माझ्याकडे नाही, इकडं पॅटर्न रिकॉग्नाइज करायला शिकायला पाहिजे. Exactly. Yes. This is logical landing. म्हणजे काय होतं? Bit by bit file, 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 file. This is simply what? Logical landing, right? So content of register with accumulator, yes sir, ending, or content present at address HL is ANDed again with accumulator, right? So this is basically logical ANDing. ANI 8-bit data. Yes, logical and immediately data present in instruction, right? This is how ANI works. Okay. So next is ORAR or ORAM and ORI 8-bit data. Yes, logically odd with either register given in instruction or memory location pointed out by HL pair or data immediately present in instruction, right? So accumulator is logically ended with any of the mentioned thing, right? Either register or memory location of immediate data. Next is XRARM. Or XRI 8-bit data. बोला exclusive or so content of accumulator is exclusively odd with either register or memory or data immediately present in instruction. Result is stored in accumulator, right? So this is simply exclusive of OR operation का है. What is exclusive OR operation? Okay, high output for different input, right? Otherwise, if inputs are same, it's loop, right? So this is simply an exclusive operation or exclusive ORing, right? So this is how those and OR works. Hmm. Yes, exactly. Complement accumulator. Whatever contents are there in accumulator, complement those accumulator. ठीक है असल? No, no, no. Carry flag. आता सी म्हणतो जनरली तो पॅटर्न काय होतो की आपण फ्लॅग जे आहेत ना ते हे रेजिस्टर आणि कंपॅरिझनला प्रॉब्लेम येतो तो कॅरी फ्लॅग जनरली म्हणतात नोटेशन यूज करतात अदरवाईज ना बुक्स मध्ये बघितलं तर तुम्ही ते सी पी वगैरे सिंगल लेटर यूज केले बट जस्ट टू differentiate with register C since it is 8-bit processor you need to write this CY बाकी मग पॅरिटी झिरो साइन असं लिहिलं तरी चालतं ऑक्झिलरी कॅरी काय आहे आणि हा सी लिहितात बट फॉर डिफरन्सिएशन इन बिटवीन युअर रजिस्टर सी अँड carry you need to write CY over there right this is simple thing you need to understand की CY तुम्ही लिहायला पाहिजे म्हणजे ते लक्षात येईल right so this is what complement carry this is complement content of accumulator. Hmm? Exactly. Set carry flag. Set carry flag. This is set carry flag. Next instructions are rotate. Okay. So those are rotate instructions. Rotate, right, and carry. Rotate. आता काय rotate करायचं? Accumulator. Right? Content of accumulator is you're going to rotate. So rotate, right, and carry. Rotate accumulator right through carry. Rotate accumulator left and carry. Rotate accumulator left through carry. ठीक. त्याचं meaning सांगतो मी. आता राईटला म्हणजे कुठं व्हायला पाहिजे? इकडं. Right? So contents of this bit. If this is D7, D6, D D6, D5 up to D2 and D1 and D0. Right. So content of this D7 is shifted to content of D5 is shifted to D6 is shifted to D4, D5 to D4 and so on. D1 to D0, D0 to D7 and carry. Right. D0 to D7 and carry. आता through carry हे दाखवतो मी. See, if suppose this is my this carry flag. Left ला म्हणजे कुठे जायला पाहिजे? So this is my bits D7, D6, D5, D1, D0, D2, right? So D0 to D1, D1 to D2, D2 to D3, and so on till D5, D5 to D6, D6 to D7, D7 to carry, and carry to D0, right? Carry to D0. This is basically to carry. And here, yes, and carry, right? So contents are there in carry as well as in D7. The same contents are there, but in this case, contents are rotated. So D7's contents are there in carry, and carry's contents are moved to D0. Right? This is how those instructions work. Right? So try this for RAR and RLC. Try this for RAR and RLC. This is rotate accumulator left to carry. This is rotate accumulator Right? True carry. बुक मध्ये दिले की रोटेट अक्युमुलेटर लेफ्ट टू कॅरी असं म्हटलं लेफ्ट हँड टू कॅरी असं म्हटलं किंवा तुम्ही म्हणू शकता की हँड कॅरी असं म्हटलं तर ते जास्त अंडरस्टँडेबल राहील तुम्हाला. Okay, so this is all about logical instruction. Stop here. The branching instruction on and machine control instruction in next lecture.